Good morning.
Morning.
So I have here in this list that I'll get this on D2L so you have something to look at to sort of flow with what's going to be on test 3. But it's pretty much a bunch of chapter 9 and a bit of chapter 10. We've done some of chapter 9. So you see, covered November 7th. This was Friday. Covered November 7th. And this is general. This delta H of reaction. It's delta H in general. Or this. But this is also called reaction energy. And it's also called enthalpy. In general, the delta H means the reaction energy, enthalpy of reaction. Sometimes we just say enthalpy. But it's all about the way energy works, mostly in chemical reactions, but sometimes physical reactions as well. So I talked about reaction energy and how you do some stoichiometry with it. I will pick up there, but let me go to, here's what I have for quizzes. You guys should see test 3 practice quizzes. I suppose I'll make all these quizzes for you. And I put coming soon on these because just so you have something to reference, even though I haven't made these quizzes yet. But test 3, I should have all the quizzes on here, so you should just be able to reference where you are in the material looking here. But I'll get these put up together soon. But let's look real quick at chapter 9, general info. Here's kind of a quick review of the energy stuff we've been talking about. Maybe I should. Just to be nice to those who skip 8 a.m. class. Move the camera. Have to restart the video. And maybe this helps now. So this doesn't involve calculations. This is just the general information. So when delta H is negative, bonds formed in the products are stronger or weaker than bonds formed in the bonds broken in the reactors. Do you remember this? I'll do the camera here, so I'm going to write on the board. general, I wanted to make a diagram. I said, this is energy. This is the reaction. Going that way. You start with reactants at some energy level. Energy goes up to some point, and then it goes down to some point in the products. I like energy diagrams like this. Your book does it as which is the way I drew it the other day. But the point is, this is the energy going into the reactants, and here's the energy coming out to form the products. Do you remember this from Friday? Okay. In this case, here's where energy started, and here's where the energy ended. So here, energy went in, energy went out, and this difference here is the delta H. All right, here's the energy that went in to break the bonds. Here's the energy that came out when the bonds formed. So for a reaction that I've diagrammed here, are the bonds in the reactant stronger or the bonds in the product stronger? Say it again. Reactants have, it's products for this. So anytime you break a bond, you have to put energy in. And when that same bond forms, that same amount of energy comes out. The reactants, you break some of the bonds in the reactant, maybe all of them, and then new bonds form for the products. If more energy comes out than went in, when more energy comes out than went in, what do you call it? Exothermic. This is exothermic. This is how much energy came out of the reaction. This is energy going in, here's the energy coming out. Overall, this is the energy that came out, but you did not put in originally. This delta H, when it's exothermic, is negative. Just say negative. Because it lost energy. In this case, energy in the reactant bonds are weaker overall than the energy in the product bonds. Because more energy came out when those bonds formed than energy went in. So the semantic information in this quiz that we got up here is all about this type of stuff. You guys follow this? Maybe rewatch the video from Monday. This is what we spent Monday talking about. The alternative is endothermic, where you come down somewhere above here. Endothermic. So that's the products. So you start here, but you end up here. That's the delta H, and not only that's the amount of energy that went in overall. So in this case, it took this much energy to break bonds, but this is the amount of energy that came out to form the products. So here the bonds are weaker, here the bonds are stronger. Quick review of stuff we talked about Monday.
So this one, the reactants are.
Sorry?
So for this one, the reactants are strong.
Yes, here the reactants are stronger bonds than the products. You guys okay with that? So that quiz is up. I think maybe the only thing to mention here is, I think you can answer those. This about which bonds are strongest, it's just which one of them has the highest value in that chart, in this chart. Average bond energies, this is table 9.3. Whichever one of these has the largest number, that's going to be the strongest bond. So the higher the energy in the bond, the stronger the bond. control of those. That's all based on what we talked about Monday. And I talked about that. I talked about being able to estimate the bond energies, estimate delta H from the bond energies on Monday also. I just don't have the quiz built for that. I also did on Monday this quiz, reaction energy stoichiometry. So this I want to cover a little bit, because I only showed you one way to do this. So look at question 2 on the quiz for section 9.6. Reaction energy stoichiometry. How many kilojoules are released when 3.5 moles of C2H4? So C2H4. This is delta H equals negative 137 kilojoules. How much energy is released when 3.5 moles of C2H4 reacts? And all you need here is the absolute value, 137 kilojoules for every 1 mole. That should give you the answer to that one. Yeah. Does that make sense? This is the idea that there's 3 relationships here. One of them is 137 kilojoules to 1 mole of C2H4, 137 kilojoules to 1 H2, 137 kilojoules for 1 mole of C2H6. Adding this to the chemical reaction just gives you these 3 relationships. And in this case, we were asked about C2H4. So it was this relationship that I used. That's from this problem.
I was just saying, would, for 137, you're not be negative?
How many kilojoules are released? Since it says the word released, the negative and positive kind of don't matter. It's implying it's negative, but you know it's negative just from the delta H that's showing here. So you would calculate it this way. All right. How many kilojoules are released? All right. Given moles. The next one I've got here is given grams. So this next one is saying, right here. Oh, it's okay, you have C2H4 plus H2 plus C2H6. Delta H, this is given in the problem. Delta H is negative 147 kilojoules. All right, now it's saying given 55.23 grams of C2H4. What was it? 55 what?